Here we have a pre-calculus problem. Okay, let's go to the question. Determine the limit, that is limit extends to positive infinity e to the power of negative 5x. Okay, now let me write the given limit as it is. It is limit extends to positive infinity e to the power of negative 5x. Okay, so before I apply the given limit for x, that is infinity for x, what I need to do is I have to change the sign of the exponent from negative to positive. So if there is negative sign, and I will have some complications when I apply the limits like infinity for x. So that I just want to change this negative exponent as positive. So for that, what I need to do is I have to consider the number we have in front of the z. Actually, we don't find any number in front of the z. So we have to assume there is 1 multiplied over here. So now to change this negative exponent as positive, what I need to do is I have to move this term to denominator. So when let me write the limit, given limit, that is limit extends to infinity. Okay, now I'm going to move this term to denominator. Then we'll have 1, this 1 in numerator. And in denominator, we'll have e to the power of positive 5x. Since I move this term to denominator, automatically the sign we have at the exponent, I mean the negative sign we have at the exponent will become positive. So whenever I move a term from numerator to denominator or denominator to numerator, so the sign of the exponent will change. Okay, now we have 1 over e to the power of 5x. Now what we can do is we can apply the limit for x. That is, we have to plug in this positive infinity for x over here. So then we get 1 over e to the power of 5 times positive infinity. Okay, it will result what? So 1 over e to the power of, so actually what is positive infinity? Positive infinity means it's a very large positive value. Okay, when a very large positive value is multiplied by 5, what will be the result of the product? Again, it will be a very large positive value, so it can be written as infinity. Okay, now we have to evaluate this 1 over e to the power of infinity. Okay, what is actually e? E is called a mathematical constant, and it's actually it's an irrational number, and it's a mathematical constant. Its approximate value is 2.71828 to the power infinity. I just plugged in the value for e. Okay, now so this is a positive value greater than 1. It is raised to the power of infinity, which is a very large positive value. So how do we have to evaluate this one? Okay, for that, let's consider a small example over here. So let me consider a positive value which is greater than 1. Say it is 2. So if the exponent of this 2 is 1, what is its evaluation? It's just 2. Okay, again, I consider the same positive value 2, which is greater than 1. Now, I'm taking the exponent 2 this time, so it becomes 4. Now, I take the exponent 3, it becomes 8. I take the exponent 4, it becomes 16. So, and now I take the exponent 10, it becomes 1024. So, here I have taken the base is a positive value, which is greater than 1. So, when I take exponent 1, for that one, I'm getting 2. So, when I gradually increase the exponent, that is 1, 2, 3, 4, 10. So, what's happening in the value of the power we have on the left side? It keeps increasing. That is 2, 4, 8, 16, 1024. So in this way, when I take 2 to the power of infinity, that is, I'm taking a very large value as exponent for this 2. What will happen? What will we get over here? So just now we saw that when I keep on increasing the exponent for a positive value which is greater than 1, so the value of the power is getting increased. So when the exponent is larger and larger, the value of the power is also larger. So when I take a very large positive value as an exponent for the value 2, which is greater than 1, so the value we have on the right side will also be a very large value, very large positive value, so that we can write as infinity. So the same thing we have to apply in our problem. So here we have a positive value greater than 1. So for this, we take a very large positive value as exponent. So then what is the result of this one? So it will be a very large positive value. It can be written as infinity. Okay, now we have to evaluate this 1 over infinity. So how do we have to evaluate this 1 over infinity? Okay, let's consider one more stuff over here. So now let me consider 1. So, and I consider this 1 as numerator, and in denominator, I'm taking 2. So what's the value of this fraction 1 over 2? Is 0.5. If I take 1 over 10, what's the value of this fraction? It will be 0.1. So if I take denominator 100, that is 1 over 100 equals to 0.01. If I take the denominator as 1000, it will become 0.001. If I take the denominator as 10,000, so what will happen? So 0.0001. So look at here, I keep the numerator same, and I keep increasing the denominator 2, 10, 100,000, 10,000. When I keep on increasing the denominator, what's happening in the value of the fraction on the right side? It keeps on decreasing. So like look at here, when I take some large value 10,000 as denominator, so the value of the fraction becomes too small, that is 0.0001. So it's almost close to, it's getting closer to 0. Okay, so in this way, when I keep on increasing the denominator, at one stage, I take a very large positive value, that is infinity as denominator. So what will be the value of the fraction? Even when I take denominator 10,000, the value on the right side will be 0.0001. So it's too small. So when you take very large positive value as denominator, so it will be close to what? It will be close to 0. So it will be too small, that is 0. So whenever I divide a finite real value 1 by infinity, it will become 0 because we divide 1 by a very large positive value. So the value of the fraction will be too small, that is 0. So the evaluation of the given limit equals to 0. So the correct answer choice for this question is option B.